The following is a series of textbooks I used in high school, college, and post-college. Let's just go down a list. In elementary school, I used mainly the Made Simple and the Easy Way books by NTC and Barron's, respectively, they're a bit rote and they're a bit programming. They're more concept orientated with a little bit of facts. Not really like a regular textbook where you're just studying problem solving. It's more just interesting in the concepts. These are all the pre-calculus and pre-physics and pre-chemistry books I learned in elementary school and middle school. It means like anything pre-calculus based. I just refer you to those. I guess you could use a standard high school text. I really don't prefer it. I guess the standard for physics is Conceptual Physics by Hewitt. In chemistry, I don't really have a favorite. Maybe Zumdahl or something. Pre-calculus Zumdahl for general chemistry or rather high school chemistry. Don't really have a favorite. In physics, I would tend to use Epstein, Louis Epstein's Thinking Physics, Gedanken Physics. For calculus, I use Thomas Finney 7th edition, and the 8th edition, and 9th edition, 10th edition are a lot more mediocre than the 7th edition. The 7th edition is really pretty outstanding. There's others like Anton Swakowski. There's other calculus books you can use, but I prefer Thomas Finney 7th edition. You can also use, I think for general chemists I use Zumdahl, Macquarie Rock, I guess that's all I have in mind. But for general physics, I know quite a few. There's Halliday-Resnick Walker, Sears-Zemansky Young, Giancoli, Survey, and Feynman. I don't really prefer Feynman. He doesn't provide a lot of problems to solve. He's a little bit overly elaborate on proofs and like conceptual demonstrations. I prefer Halliday-Resnick. Likewise, for general chemistry, I prefer Zumdahl to Macquarie Rock. So you get a student solution guide for Zumdahl. It's harder for Macquarie Rock. For biology, I definitely prefer Campbell. It's kind of a nice, even approach, a lot of facts, a few concepts here and there. It's not just zoology, though, or like stamp collecting. He actually does get into some theoretical apparatus. Campbell does for general biology. For general electronics, I prefer AC/DC. I prefer Floyd. I don't really know that many others. There's a famous Zenith Heathkit set. I've never really looked at that. I believe it's programming based. I don't really have a preference for the engineering side. I just tend to use Calc. Thomas Finney 7th edition, Halliday-Resnick 3rd edition. You can use Tipler for general physics too. It's not a bad text, particularly the second one, which is proof-based. The other one, the later ones get a little bit more mediocre, but it's not bad. Thomas Finney 7th edition for physics. Halliday-Resnick 3rd edition for physics. Calculus rather for Thomas Finney. And Probably Zumdahl for general chemistry. Um, for second year or third year of physics, chemistry, and math, linear algebra, I prefer Strang. For linear algebra, for differential equations, I prefer Boyce de Prima. To Inc, Tenenbaum, Brown. Actually, Brown is superior to Boyce de Prima, but it's not heavy on problems, so I prefer Boyce de Prima. For probability and statistics, I prefer Kalflesh and DeVore. Those are two separate textbooks. That covers design of experiments too. For thermal physics, I prefer Schroeder. For Lagrangian mechanics or classical mechanics, I prefer Goldstein. You can also use Thornton and Varian. It's a lot weaker though. For electrodynamics, I used to like Purcell. Nowadays, I prefer Griffith. Griffith isn't heavy on problem solving. He doesn't. I don't think he's just not heavy on problem solving. You almost need to have the electromagnetism problem solver, the Shalom's electromagnetism book to go along with it. For organic chemistry, I prefer McMurray to Wade or the blue book. I think it's called Marion too. It's called Marion. Morton. It's called Morton. I prefer McMurray to Morton and Wade. For physical chemistry, I prefer Atkins. You can use something more advanced like Daniels Alberti or just Alberti, like 4th edition or 7th or 10th edition. I prefer Atkins, 3rd or 4th edition for PChem. For analytic chemistry, I prefer Skoog or I forget the other, Harris. For classical mechanics, I don't really have a favorite. You can just use any of the lay books out there. Not classical mechanics, but like modern classical physics, like just a precursor to modern physics. You probably would be better off using what's his name? Mach, Ernst Mach. His classical treatise, a good introduction to mechanics. Or you could use de Hartog for classical physics. For quantum physics, I don't really have a favorite in quantum physics, like precursor to quantum mechanics. Quantum mechanics, I prefer Budkov. It's the classical exposition in mathematical physics. It's not purely quantum physics, but it's an excellent introduction to the mathematical methods behind. Covers everything up to quantum mechanics 3 in the graduate core. So it's an excellent book for all things, and it's one of the easiest books I've ever read. And for quantum mechanics, you could use Griffith. It's not bad for undergraduate quantum mechanics. For quantum mechanics 2 and 3, I prefer Marsden. For solid state physics, I prefer Ashcroft Merman. For biochemistry, I prefer Leninger to, I think his name is Meserve or something. There's not really a favorite for the other fourth year chemistry disciplines like nuclear, electromagnetic, water, environmental, soil. I don't really have a favorite in those textbooks. You just use whatever, like a basic engineering text. For chemical engineering, I prefer, Pauling Wilson, the Dover book. For nuclear physics, I prefer Griffiths. Undergraduate text, you're better off with the graduate text because you start to get pretty formal at that level. For group theory, I prefer Artine, Modern Algebra 1 and 2. For tensor analysis, I prefer Springer-Verlag's A Brief on Tensor Analysis. I prefer, in group theory, I prefer to, I think his name is Wilson, the Dover book, the big Dover book. His name is Wilson or something. I prefer it to Artine to Wilson. For the engineering core, you can just follow Budkov and many of your undergraduate physics texts. For upper division electronics, I prefer Floyd all the way up to op amps and solid state. Just a very well-rounded textbook. It's problem oriented with nice color pictures. There's a lot of problems to solve. You can look at it in VAX, figure out the solution from it. Let's see, we're almost at graduate level. For graduate level quantum field theory, I prefer Kaku, Weinberg, Roman, and Schroeder. For 1 through 3, it covers all the way up to quantum chromodynamics. For relativity, I'm not really into Archibald Wheeler and I think it's Marion again. Wheeler, Thornton. I forget who the third author is, but anyways, the Big Black Book is not my favorite in general relativity. I prefer I forget his last name. It's a small book. It's like Stephen Chandler or something. A general and special relativity book. For quantum mechanics 1 through 3, I prefer Budkov and Sakurai. Sakurai gives an excellent grounding in quantum mechanics 1 through 3 at the graduate level. For solid state, I prefer Harrison's 2-volume Dover edition for solid state physics, and also along with Ascroft Merman. For optics, I prefer Bourne and Wolf. For acoustics, I prefer the Physics of Musical Instruments. It's an excellent book on physical acoustics. Covers Green's functions too for acoustics. It's probably the best out there. You can also use Rayleigh's treatise on sound and acoustics. For graduate electrodynamics, I prefer Jones, D.S. Jones, and the famous one, Jackson, J.D. Jackson. 2 great expositions. And for quantum gravity, I prefer Penrose's treatise to Green's treatise on superstrings. We're better off with quantum gravity with Penrose and Rindler's book. That covers physics. For chemistry, I don't really have preferences in graduate chemistry. You're better off with Springer-Verlag, in my opinion, but that's just my opinion. For biology, I don't really have a favorite either. For electronics, I don't have a favorite. I prefer Papelouse for linear search signal design, linear systems, and the Fourier transform and stochastic processes. I prefer Papelouse. For graduate group theory, you probably should just use go on using Artine. You can use something elaborate like some of those advanced Springer-Verlag books. For tensor analysis, I prefer Eisenhardt, Luther Eisenhardt. Riemannian geometry. For nonlinear geometry, again it's Eisenhardt. As well as coordinate geometry and other things. For differential geometry, I prefer Michael Spivak's 5-volume course. For the theory of distributions, I prefer Shilov's 5-volume course. For theoretical physics as a whole, I prefer Landau and Lifshitz's 5-volume course. For engineering, I prefer Dover. I think it's by Perutsky. In civil engineering, the matrix structural analysis. In geophysics, I forget what it's called, but it's the Dover. I think it's called Abramovitz or something. The Dover's 800-page volume on seismic waves. It's a blue book. That pretty much covers it. It's what I do in physics and math. Most of the stuff I learned in high school. I know it sounds daunting, but it's what I did. And for publishers, I recommend Springer Verlag, Addison Wesley, um, and Wiley. There's a few others I like occasionally, like Prentice Hall and McGraw-Hill and Oxford Press. And Cambridge Monographs. I tend to prefer those books for advanced science books and math, engineering. You need Strang's book on wavelets and on Fourier synthesis or finite element design. He's one of the better authors on that subject. He's pretty conceptual. He doesn't provide much of a problem set, but he's really pretty conceptual. So if you want to know what you're talking about, try Strang for wavelets and his other book, I forget what it's called, Wavelets and Finite Element Analysis. There's an excellent Dover book on finite element analysis. It's an engineering book in the 6,000 or 7,000 core. In mechanical engineering, it's called Finite Element Analysis. It's a blue book by Dover. It's highly recommended. I like it. I'm not really a fan of Dover books much, but a few of them aren't bad. For history and math, I prefer Boyer, both at the undergraduate and graduate level. If you want to get specific, you can get into something like the Springer Verlag series on particular artists, like Kummer or Euler or Ramanujan. You might diverge into Struik or Dirk Struik or something else for undergraduate history and math, but I prefer Boyer. It's a pretty big book. It covers 2 semesters. Okay, so that's pretty much what I do. Actually, I covered about twice as many books as that in high school. I forget what the others are. They're mainly ancillary subjects like fractals. For fractals, I use Heinzeit-Gopitkin and Mandelbrot, The Beauty of Fractals. I think is what it's called. It's a small silver book by Springer Verlag. It's quite theoretical. It's pretty good. Although the math is a bit done. For complex variables, I prefer Budkov. You can use Churchill. For the graduate level, I prefer the Oxford book. I forget who it by. It's a blue book with black lettering. I think it's, who writes that book? Anyways, that's who I prefer. For Banach space and linear functionals, I prefer Shilov. You can also use Shilov for measure theory, linear algebra, differential equations, and undergraduate linear algebra and functional analysis and complex variables. He's not bad. He's a little bit wordy in complex variables. Doesn't really get to the heart of the matter. He's more interested in proving stuff. Isn't really as conceptual as complex variables can be. That's where I prefer Budkov. Well, anyways, that's what I like. If you have any comments, comment below. I'd love to hear from you.